Here we go. So, can you figure out which pattern number will have 43 trees? 43 trees. Whoa. We're on page 79. Well, this isn't on your page, but that's where we're going to be headed. Okay, write down your number in like a corner or something if you have it. Because I want to see, are people like, okay. Anybody got a number? Come on. That's not what I got, but maybe I'm wrong. Oh, people. You got a number? Anybody got a number?
You said what number?
Oh, 70. Well, I didn't say what the number is yet. I'm asking you. Somebody else wrote a number. We're on page 79 is where we're going. Phone away. I know you have a number. I saw it. You got a number? Ooh, that's not what I have. Maybe I did it wrong. It's very possible. Anybody else got a number? You got a number? Write it down somewhere. Yeah, I need to clean these desks too. Shoot, that's not what I had either. Let me think a minute. Oh wait, let me look at your numbers again. I think I did make a mistake the first time. Do you have a number? You have a number? You have a number? Do you have a number? I can't see it. Okay. Number? Number? What's your number again, Eli? Okay. Che, what are we doing? There's calculators over there. All right. So, how would we figure this out? I saw numbers of, great, all that time I was doing it. I saw numbers of this. I saw a number of this. Did I see any other numbers? So how would we figure this out? What's the pattern going on here first? Because we've had this pattern before. Yeah, Cameron. So 42 divided by 2, which gives you 21, yeah? Plus 1, okay. Anybody else? So what's the pattern that you see? What shape do you see in the fourth? Jay.
What I did was 2 in parentheses n plus 1.
2 in parentheses times n plus 1.
No, 2 is in parentheses.
Oh.
N plus 1 on the outside.
2 is in parentheses. N plus 1 like this?
Yeah.
Okay. How did you get that?
Because of the 2 on figure 1 in the other tree.
Okay.
It keeps like multiplying.
Okay, and it's always that plus 1 though, right? All right. So I think you all have the right idea, but you're going to get different answers. And how does that, did you get a number then?
Yeah, 21.
21. Okay. So, Nehemiah, what were you going to say?
I just kept going in that same style with like the rectangle of trees.
Uh-huh.
That to 21 because 2 times 21 is 42.
Mm-hmm.
And 1 you got 43.
Yeah. Did we have to do the whole thing though? Because you're right, this is a rectangle plus 1. Does everybody see that? You need to start visually seeing these kinds of things. It's a rectangle plus 1. And each time the rectangle is getting bigger, right? So this is a size of a rectangle of 2 by 1. Over here, it's a 2 by 2. Here, it's a 3 by 2 plus 1. So we should be thinking if it's going to be what we're looking for, which is the, what is it called? The pattern number. The pattern number is always the same as what you're multiplying by 2. So it's some number times 2 plus 1 should equal that 43. You can almost make it into an equation. Now I would simplify this and say, okay, that's 2 times some number plus 1 equals 43. Does everybody see that? It's always plus 1. So if you go in reverse, get rid of that 1 tree, and that's a little bit where you didn't quite get it right because you added the 1 at the end. And you get 2 times some number gives you 42, and that means the number we're looking at must be 21, so that is the number of your pattern. But each of these rectangles is a 2 by something, and that something happens to be your figure number. Okay? Questions on that? Now, this right here, when I say 2n plus 1, what do we call this? What do we call this in general? Is that a variable? Is that an equation? Is that an expression? It's an expression. What kind of expression? It is linear, yes, because the variable is to the first power, or there's no exponent on it. It is linear. It is an algebraic expression, correct? So, yes. What? You have a question? Okay, I'll be right there. So I saw on the test lots of times people were giving me numbers. You know, they'd give me an answer, but then they would say, like, the algebraic expression was 2 times 40 plus 5. There's no algebra in there. Those are all numbers. So the algebraic expression was the part with the variable. Okay? All right. Let's go on to the next one. So task number 2, page 79. This is what the main part of our lesson is about. Okay? I'm going to read this to them, and then I'll be with you, okay? So, everybody following along, paying attention. All phones are away. 3 girls downloaded a total of 36 songs onto their iPods. Boy, you can tell this is old now, can't you? Jane downloaded twice as many as Inez. And since Tracy wanted to have the most downloads, she downloaded 1 more than Jane did. How many songs did each girl download? Okay. I'm going to give you a couple of minutes just to... 3 girls download a total of 36 songs onto their iPods. Jane downloaded twice as many as Inez, and since Tracy wanted to have the most, she downloaded 1 more than Jane did. How many songs did each girl download? All right, how would you approach this problem? Give me one bit of information that you think is significant for this problem. Yes, slay. That is excellent. A total of 36. Did she really just say slay? Yes, she did. Equals 36. That is the most. Okay. What else? What else is going on that's important? Nehemiah's like, I'm taking the easy one, the easier one here. Yes. Twice as many. Who's got twice as many? Jane has twice as many as who? Inez. Okay, Jane has twice as many as Inez. So question, are we going to use a variable here? Are we going to just guess and check? Could we guess and check? You could. But algebra will make it a little bit simpler. But you could guess and check. Did anybody guess and check? Did you? Good. Okay. Did you get an answer? Does it work out? Okay. All right. I'm very happy for you. We'll see if the answers match up. And if you can't do anything else, you can do guess and check. But I think there's another way. I think I started to say this. Do you think we're going to use a variable here? Is there some unknown amount? Is there 3 unknowns? Kind of, but they're all in terms of one variable, right? Who is going to be the one person we're basing all of our other expressions on? Yes, Inez. Because Jane had twice as many as Inez. Okay, so let's write down these girls' names. We have Inez. We have Jane. And we have Tracy. Right? Okay. So Jane has twice as many as Inez. Right there, Inez is our basic person. So how many do we want to say that she has downloaded? I just didn't hear you. 7? How do you know she's got 7?
Why?
Do you know 7? Do you know it's 7? Well, if we don't know, what should we call it? X. Yes, let's go with our favorite variable. So Inez has downloaded X number of songs. Okay, everything is based on Inez. Tracy thought it was all about her. It's about Inez. Because Jane then downloads twice as many as Inez. So who haven't I talked to? I have to think about this. Yasmin. How many downloads does Jane have? If Jane has twice as many as Inez, and Inez has X. Yes, excellent. She has twice as many, so that is 2 times X, which is 2X, right? Twice as many. All right, so we got Jane. And finally, Tracy. Tracy, I think, should have been a Stacy, you know. She wants to have the most. She downloads 1 more than Jane did. How many did Jane download? Not 3X. No, not 3. Jane downloaded 2X. So, Jaden, how many is Tracy going to download? If she wants 1 more than Jane. Yeah, well, how many did Jane download? Yeah, but we gave it a value. What's our value? Okay, and then she downloads 1 more, so that's going to be 2x plus 1, right? Oh, yeah. Okay, all right, I can play this game. So now what do I do with all these? Yeah, the keyword was total. What operation do we do when we total things? Do we add, subtract, multiply, or divide? Add. So here we go. Here's Inez. She downloaded X number. Jane, she downloaded twice as many. So that's plus 2x. And Tracy, being Tracy, had to have one more than Jane. So there are all three of their amounts. Okay, now what do I do? Combine like terms. Where are my like terms? All the x terms, right? What is 1x plus 2x plus 2x? 5x plus 1 is equal to 36. Can you solve that? Please say yes. Please say yes. Yeah. Subtract 1, subtract 1. 1's cancel out. 5x is equal to 35. And Che, you were right before. So x is equal to 7. There, I've answered the question. That's the end of the problem, right? And they want to know how many did each girl download. Well, x is 7, so how many did Inez download? 7, because she is x. How many did Jane download? 2 times 7, which is 14. And good old Tracy, she downloaded 15. How could I check this just to make sure it's on the up and up and correct? And add them and what? It should equal 36. So 7 plus 14 plus 15, 5 plus 4, 9, 7, 16, 36. Booyah. There you go. So this is Inez. She downloaded 7. Jane downloaded 14. And Tracy downloaded 15. Could you do a similar type problem like this? You have to find one person that it's all about. Okay? Could you do this? Did you get these numbers?
Yeah.
Very good. I'm very glad you did, because if you're not sure, that's how you do it. However, I will say for this test, this is called equations. So we're looking for the equations. Can you put together an equation from a word problem like this? Okay? Let's go to the next one. All right, so we're trying to come up and build equations. A checking account is set up with an initial balance of $4,800. $300 is removed from the account each month for rent. No other transactions occur on the account. How many months will it take for the account balance to reach $1,500? We're trying to come up with an equation. Right, Karan? All right. I'll read it one more time. Checking account, set up, initial balance. What's an initial balance? What does that mean? Yeah, the start. How much you put into the account to begin with. $4,800. $300 is removed each month for rent. No other transactions occur on the account. How many months will it take for the account balance to reach $1,500? Now, how am I going to start this problem? Anybody got any ideas? Aiden, you said you had something. Did you get an equation with it?
Yeah.
Okay.
I did
4,800 minus 300x equals 1,500. Okay, and what is your x equal to? What is that? Okay, it probably is. Jesse, you cracked me up. But what does it represent?
Oh, it represents the month.
Yes, number of months. And it probably is 11. Okay. Months, not mouths. All right. So we started with the total amount we were given. 300 is removed from the account each month. So month 1, it would be 300 times 1. Month 2 would be 300 times 2 because the total would be 600. The third month would be 3 times 300, etc., etc. We're trying to solve for X. Oh my, how would I do this? Because it's got a big number over there. What would I do? How would you solve it algebraically? Subtract what? Say it again. Yes. So you've got only one x here, so I wouldn't move the x. Usually we say, subtract the smaller from the larger, but I want to move the other number, so I don't have to move my x amount. So these cancel out. Check the sign in front. Negative 300x is equal to, what is that, 3,300? Negative, thank you. Yes, that's kind of important, isn't it? All right, I'm solving for x. Right now, what's happening between negative 300 and x? It's being multiplied. Why do I feel like this is the Stephanie Thede show? Come on, people. So divide by negative 300. Divide by negative 300. 300 cancel out, and x is equal to 11. 11 what? Months, yes. And you will also realize in the coming days and weeks that I'm a big one for, you need to label it. I'll say, are we talking about pink flamingos, purple tutus, king crowns? What are we talking about? Okay? Questions on that one? Rodney. Are you with me? Okay. All right, let's go to the last one. Peyton. Well, gee, I wonder where we got that name from. Peyton is 3 years younger than Justin. Matt is 4 times as old as Peyton. If you add together the ages of Justin, Peyton, and Matt, the total comes to 39 years. How old are Justin, Peyton, and Matt? Oh, this sounds just like one of those problems, right? Let me read it again. Peyton is 3 years younger than Justin. Matt is 4 times as old as Peyton. If you add together the ages of Justin, Peyton, and Matt, the total comes to 39 years. How old are Justin, Peyton, and Matt? Here we go. Peyton is 3 years younger than Justin. Matt is 4 times as old. If you add together the ages of Justin, Peyton, and Matt, the total comes to 39 years. How old are Justin, Peyton, and Matt? Give me one piece of vital information that we know here, or we need to know. Peyton is 3 years younger than Justin. That is vital. Yes. Okay. What else is vital? Say it again. Total is 39. Where is that? Yes, down here. Total comes to 39. When you say total and they give you that, it's always probably going to be equals, and that's going to be at the end. It's always going to be at the end of your equation, right? Okay, so Peyton is 3 years younger than Justin. Yes, were you saying?
I was just saying, I think like Justin would be what you're basing.
Yes. So Peyton is based on Justin, and Matt is based on Peyton. But if Peyton is based on Justin, then Justin is our main man. How old is Justin right now? I don't know. Yes, he is my ex. He is the one I'm basing everything on. So everybody see that? All right, so I have Justin. Peyton is 3 years younger than Justin. How would I relate Peyton, and what is his expression then? X minus 3. Okay, X minus 3 because he's 3 years younger. Then Matt is 4 times as old. 4 times as old as Peyton. How do I show Matt's age? 4 times as old. Pierre, how would I show that? Say it again. Try again. Where is that? 4 times as old as Peyton. How old's Peyton? Peyton is x minus 3, right? What did you say? Maybe I didn't hear you. Not just 4x. Peyton is x minus 3. You want it to be 4 times Peyton's age, so that means 4 times x minus 3, right? Does that make sense now? Okay. Can I simplify that a little bit? Matt's age. Just say yes. Yes, yes. What would it simplify to? Yeah, we use that distributive property. Then what do I do? What do I do next? Come on, we're almost there. We're almost out of time. I know you're like, I'm hoping. Come on, what do I do? Yes, you add them together. So here's Justin. Here's Peyton. Oh, not plus, minus. And here's Matt. With his simplified age, they all total 39. Combine your like terms. 1 xylophone plus 1 xylophone plus 4 xylophones gives you 6 xylophones. I can also combine my numbers. Minus 15 equals 39. We'll finish this tomorrow. You can start the first homework in this chapter. All right, have a great